Rashmi here. Welcome back to another video, and this one is also about coding. So, since I've been learning, Python with UTech, I just completed my final project. I thought, why not I share my knowledge with you guys? My instructor is Miss Laiba, and she is a very nice and kind instructor. She taught me everything I knew, everything which was supposed to be taught to me, and I understood it very well. And she also answered my queries if I had any. So let's get started. So, this is the regression task. An assignment from UTech. The annual temperature. We will have to predict the temperature in 2016 and 2017 using the data of the two countries. So of course there's supposed to be some data set of two countries, and we are gonna predict the temperature in 216 and 17. So we're gonna find it out by using linear regression and polynomial regression along with comparing the accuracy. Means you're gonna compare the linear regression's accuracy with the polynomial's accuracy to see which one is more better, linear or polynomial. So let's get started. So as you can see, I have already been given a drive where the data sets are supposed to be. So if you have one like this, or you already have a data set, you can work with it. So you're gonna click on annual temp two times. You see this is all the data set. This year means the year what is the temperature of it. So we are gonna click this button which has an arrow and pointing towards the tree, and below it it says download. We're gonna click on download, and there it is. After it's done, we click on this arrow and click show in folder. We cut it from there and upload it in our folder. Not on the desktop folder, the inside folder, like the data D. I have already a folder, so I'm just gonna paste it over there. Since I already have this, I'm not gonna do it again. But for you, you have to do it since it's your first time. So from here, you're gonna click on this, and it will all be highlighted. You click CMD, and from there you type Jupyter Notebook. After you're done with that, you get this page, Jupyter. These are all the notebooks I have done so far, and we are gonna do the predicting the temperature. So I'm gonna take a new notebook, and we are gonna do this step by step together. First of all, we are gonna import the libraries. Python is a huge bookstore, and the libraries are small books inside it. Imagine. Import pandas is one of the books. Import matplotlib.pylot is a second book. And import numpy is a third book. And we need all these books to get our information, the codes, the function. So let's do this. It doesn't matter in whatever order. You can do the pandas the third, the matplotlib the second, it doesn't matter. We are gonna click on run. Now we're gonna wait, when it says one, means it ran successfully. Or when you see the star sign, you know, when you see this sign over there in the square brackets, you means it's still running. But if there's an error then and it still shows 1 means there's an error and there is a typo in your code. It doesn't always mean a typo. It can mean anything. So let's move on to the next step. It is to import or to get the computer to read the data set. We need the exact same to same spelling, whether a is capital or t is capital. We need that, otherwise the computer will get confused and ask, which file are you talking about, miss? We don't have any such file here. And when you're trying and you're saying, oh no, there's that file, the a is capital, I just make the a small, and the computer says that no, you're supposed to do this, you're supposed to make the a capital too. It all says this in the error. So now make a variable. We're gonna make a variable df here. So df is equal to pd dot read underscore csv. Df will store our what we say data set, and pd is our short form of pandas. So data set is equal to pd dot read underscore csv. We're gonna have round brackets and inverted commas here. So this is my data set. I'm gonna copy paste this from here because I cannot risk any errors. Means the computer trying to communicate with me. Okay, now that we're done, the I'm gonna print df as it is over here. I'm gonna run this out and remember, always check your spellings. There we go. So we have our source, the year, and the mean. What is mean supposed to be? Yes, the temperature. Now the next step, it is to drop a column. Why do we need to drop a column? Because it is no use and it's giving us error again and again. So why not just remove it? So we're gonna use the function drop. So df.drop, we're gonna write in brackets inverted comma source. After this is inverted commas, we're gonna put in comma axis 1, and of course we want it to be permanent, so we'll write in place is equal to 2. We're again gonna print we're again gonna print the data set. So here we're gonna drop source. Let's run it, and here we go, year and mean. So 272 rows and 2 columns now. Earlier it was 3 columns, but now it's 2 columns. Let's check out what's next. Yes, it's the iloc function. Iloc. What is it basically? So it's a function that helps us to get a specific row or column from the dataset. So here, x is year and y is mean, means temperature. Remember of the dashes, guys? We're gonna do it. So x.df.alloc, we're gonna put one column just like this. It's not this column, guys. Don't confuse it for a semicolon. It's just a column. We're gonna give comma another column with -1, and then we're gonna close the brackets. Dot values. Same for y, but we don't need to give that extra column. Like here, it will be the same, but we don't need it, so we're gonna remove it. Now we're gonna run it, and it ran successfully. We're gonna print x like over here. It has all the years. It's up till 18, 80. Now we're gonna print y. the temperature. So, what is the next step now? It's to get another book from the Python library, the sklearn.model selection. Oh, guys, remember I gave you one example? So, sklearn model selection is a book from the Python bookstore or the library. And from that, there's a chapter called Train Test Split or a page about Train Test Split. And we really need it. So we rip it off and get here. So from sklearn.model section, means from the book sklearn.model selection, we are gonna take the page Train Test Split. X train, X test, Y train, Y test is all equal to train test split. In the brackets, we're going to write X, Y, and the test size is going to be 0.25. And now the rest of it will be train size. We don't want any random values popping out, so random state is equal to 0. So let's do this. Remember to write sklearn.model selections properly. Don't make any typo or it will, give you an error. Train test bed. This is an underscore. You press shift and there you press shift. You press shift to get it. There is also another one if you don't press shift. It's like this. It's a minus, right? When you press shift, it's like this. An underscore. Okay, now let's run it. And it ran successfully. Let's see what else. I think we have to get another book. Oh yay, I'm right. So, from the book, sklearn.linear model. Oh wow, I never knew there was such a book. Import linear regression. So there's a page linear regression and we take it and we import it. We're going to make a variable regressor which stores linear regression because we can't over and over write linear regression, otherwise it will be really tough for us and we'll get tired by typing it. So regressor dot fit means we want to fit the training set. X train and Y train. We want to fit those variables. So we are gonna write it down now. We are going to write it down now over here. So don't forget to write it wrong. Sklearn, Sklearn. Learn spelling is gonna be same, just SK you have to add. Okay. So what is the meaning of sklearn basically? It's the scikit library. Sklearn is the short form of the scikit and regressor is its variable of the linear regression. We're gonna run it now and it shows this output. And what else? We're gonna be ypred means another variable for us which is to predict y. Regressor.predict x test. So the ypred variable is gonna predict the x test variable. And now we're gonna print regressor.predict. Here we're gonna do it. So x test, x train, y test, and y train. Here we're gonna use x test. We're gonna print regressor.predict. Okay, what's the next step now? We need to import the polynomial regression. So polyreg is gonna be our variable over here. We're gonna have another variable x poly. So polyreg fit and transform x. So we're saying polyreg, please fit and transform x. So it means we want to fit and transform x so we can use it. And same, we're gonna fit x poly and y. So we're gonna make another variable. Linreg2 means linear regression 2 is equal to linear regression for now, because from here to here it's a new variable. So we have to use this. Or you can use regressor if you like, if you want to do. So linreg is, we want to fit again x poly and y. So let's do this. It's gonna show the same thing just like this, but we still need to import it because it's necessary. So what's the next step? We are gonna make a scatter plot. You know those type of graph with plots all around them, predict showing the data set. Take a look. This is the temperature and this is the year. 89, 900, 1920, 1940, and to 2020. So, in middle of 2000 and 2020, there should be, where you can say there should be 217 and 216. Right, 3 steps or 2 steps before, right? So if we go up from here, it's either zero point 0.6, 0.7, or zero point 0.8. It could be anything. So that's why I did it for all. So after we're gonna, make the scatter plot. Let's just do it. Remember, you can make any color like lavender. You need to have a code for that. So let's search lavender's code. Lavender code. So this is the code, the hex code for lavender. We are gonna write it over here if you want, because blue is gonna be the dots and yeah. So I'm gonna write it here. This is supposed to be for lavender so the computer can understand, and it can be purple. It will look super nice. And the heading, the title, the annual temperature, because if you're making for another data set, then of course you can write some other, but since I'm making for the annual temperature, I'm gonna write this. So x label is year and y label is means the mean and the year. So let's run this out. Wow, so pretty. But I never knew that lavender would be this light. So I'm gonna change it to blue. Remember, any color you like. That's better and much more visible. So, what is the last few steps to predict? So we're gonna do of linear regression. So ypred is equal to regressor dot predict 6. So you want to predict what would be the temperature in 2016. Like 2016 is here and we want to predict 6. So it's over here. So we predict it and the temperature would be minus 13. So let's run this out. If your data set is different, then of course your values will be different. We'll do the same thing for 8 and 7. I'm just gonna do it for 8 because I'm just gonna do it for 8 and here I'm gonna write 227. You can do it for both of them, 8 and 6, 8 and 6. It's also minus 13, but you see, wait, yeah. You see these values, they're slightly different, so it's not at all same. Of course, the first two values are, but the rest are not. Now we're gonna predict for the polynomial. So we're gonna print the model score, which is gonna be x train and y train. So the model and the score, like the accuracy score, like that, we're gonna print it. And model is not defined. Model is equal to, what will model be equal to now? Hmm, how come this worked then? So, so after we're done with these two, we are gonna, our final case, the problem solved. Which one is better? 13, the one that ends with like 2016 or 2017? I think they both are okay and they are, nice and okay. So, thank you so much for watching this video, guys. Don't forget to like, subscribe, and smash that bell button, and share it with your family and friends. Bye, guys.